Welcome to the class. The first thing you need to do is you need to go to aplusstudents.com. You need to go to the website. Once you're on the website, you need to select maths. Okay, so this is the website, aplusstudents.com. Select maths. This is a grade 7 math lesson, and the name of the topic is data and graphs. Data and graph. I'll give you the chapter number and the lesson number. Chapter number is 23 and the lesson number is 5. Chapter number 23, lesson number 5, and the name of the lesson is Interpret stem and leaf plots. So we will be looking at stem and leaf plots and how to process data on a stem and leaf diagram. Okay, so let's move ahead with stem and leaf. Just a moment. Okay, I'll go to the website. That is grade 7's. Sorry. Okay. Let's copy the first question. The first question says, David's PE class participated, and it's given over here. Okay. So if we move to the first question, this is our first question. This is the information that's provided on the first question. Competition. Okay. Just a moment. So the question number 1 says, David's PE class participated in a push-up competition. In a push-up competition, wrote down how many push-ups each person did. Okay, so whenever we are doing stem and leaf means this part would be the stem, right? Whereas the second part of the equation can be considered as the leaf, as the unit value of the. So the first value that we can read is, if this is written as 33 over here, and this is 4. Agreed? 34. So it would be 36 and 38. The use of stem and leaf diagram is there because in case of bar graphs and other values, a combined bar would be made for the values in 30s. But in a stem and leaf, the values would be retained. 34 would be separate, 36 is separate, and 38 is separate. They're not merged into a single bar. Okay, you are always given a key. Whenever you are doing a stem and leaf diagram, a key has to be provided. If it's not provided, we will create a key over here. The key says that 3 with 4, right, should be equals to 34. Okay, so we read 3 and 4 as 34, and similarly 7 and 8 should be 78, 7 and 9 should be 79. So what they're asking us, what is the largest number of push-ups done? So where would we find the largest number? The largest number would be 8 in the tens and 6. 86 is the largest number. Agreed? We simply need to read that. We need to find the digits because 86 would be the largest number in this possible category, right? And what were the numbers that were possible? The number possibles were, let's see, 34, 36, 38. They're not the largest, right? Then we had 45, 45, 48, 8, then we had 51, then we had 51, then we had 52, then we had 53. Okay, for 60 there is only a single number, 68. This is still not the largest for this given information. 71, 73, 73, 78, 79. We don't have to do this working, which I'm showing you over here. 83 and 86. We directly know that 86 is the largest number, whereas 34 was the smallest, right? Agreed? Okay. So we just don't have to do the entire set of working in a stem and leaf diagram. We can assess a lot of information directly from the diagram. Okay. So let's move ahead. Let's look at another example. Okay. For the next question, it says, while writing a paper or making decisions in group, Mia research the committees. Okay, 1 minute. So the second question we have, it says this information. Just a moment, please. I'll resize. While writing a paper or making decisions in a group, Mia researched the size of the number of committees. There are different committees working on that. Okay. But we need to see that no key is given to us, right? We do not have a key. If the key is not given to us, then we have to make the key for ourselves. So this question says, question number 2 says, these are the size of the members in a committee. How many committees have fewer than 80 members? Can we make the key first? Can we say the key for this question is 2 and 0, 2 with a slash 0 is equals to 20 members, right? This is the key we have. So they're asking us how many committees have fewer than 80 members. Okay, let's see. Let's see, this would be, we can read this as 20, right? This could have been read as 30, 32, 36, 36, right? This would be 45 and 45, right? So this information, this working which I'm doing over here is a little excess information. In a stem and leaf diagram, we do not have to write these numbers, right? We would save our time. We don't write these. Okay. All we need to do is have fewer. So what is a fewer than 80? Less than 80 means it cannot be 85, right? If we are looking for a number that has to be less than 80, it cannot be 85. If this was 85, it cannot be 90, it cannot be 90. So all the numbers fewer than this. So what we can do is we can simply count the number of leaves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we can say there are 12 committees. Committees having members. Okay. So we can simply count the leaves. That would give us the answer. This would be excess working. That we would be wasting a lot of time, right? So we don't need to waste time. We just simply need to read the values in the leaf. Do we agree on this? Okay. Okay, let's have a look at another example. The next question says then, okay, 1 minute, please. Now they have given us a range of values. Okay, for the next question, they are saying we have a range of values. Let me realign this first, please. So Newbury Chamber of Commerce researched the number of employees working at a local companies, right? They're trying to find the workers at the local companies. The stem and leaf has been provided to us. So, and they're asking how many have at least 40, but less than 60 employees. Okay, I know it's not readable. Let me just realign this. Okay. Okay. If this is our question number 3, and the question says the Newbury Chamber of Commerce researched the number of employees working at a local company. The stem and leaf is given to us. What they're asking us in the question is, we need to find how many companies have at least 40 employees, but less than 60 employees. They cannot exceed 60, right? Can be 40. At least 40 means 40 is included, right? We can say over here that if they're saying at least 40, that means 40 is included, right? And less than 60 means 60 is not included. Okay. So what we can see over here is if 40 is included and 60 is not included, let's find where is 60. This would be 40, 41, 41, 41, 44, 45, 47, and 9, right? Let's find 60. Any number over here would be greater than 60, right? If you wish to see as an example, this would be 61, 64, 66, 67, right? And these numbers should end with 59 and 55, right? That means this number is less than 60. It was starting at 40 and so on. That means we would include all these values over here. How many numbers are possibilities? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. That means 13 companies have at least 40 members, at least 40 employees, but at least 40 and less than 60 employees. Okay. The others would be at least 40 but more than 60, right? Let's try another. An employee at the craft store counted the number of red buttons in each bag of mixed buttons. Okay, so we are counting the number of red buttons in a bag of mixed buttons. Just a moment, please. We'll try to make more parts to these questions, okay? Let's see what else can be possible for a given question. So if this question was given to us, this was our question number 4. An employee at the craft store counted the number of red buttons, in each bag of the mixed buttons, okay? So the first thing we need to do is we need to find the key. 1/2 is 12, right? That means 12 buttons. 1 in the stem and 2 in the leaf would mean 12. Okay. So they're asking us what is the smallest number of red buttons? Kind of easy. What would be the smallest number of red buttons? See, we can say we have 12, 18, 24, 35. Whereas the largest number would be 65, right? So the smallest number we already know is 10. Sorry, 12. Do not have a 10. Smallest would be 12. Because this is the smallest, right? If I would change the same question to find the largest number of red buttons in a bag. So what would be the largest number of buttons in a bag? Since we know the extreme points are always the minimum and the maximum points, right? So 65 because 60, 61. So the largest number of buttons in a bag could be 65. Agreed? They can even ask her, what is the median, mode? That is the next part of the question, okay? That can be asked. They can ask us, what are these values, right? We have done previously mean, median, and mode. So we can use that certain information to further do these questions, okay? Okay. We would have okay, let's try doing mean, median, and mode, okay? For this information given to us. So what, sorry. I think we haven't done, okay, let's stick to this only. That would be the next topic. Nolan counted the number of silver beads on each bracelet at Arlington Jewelry. Just a moment, please. Let me copy. For the next question, it says, question number 5. This information is given to us. And, sorry. We need to process this information. Okay. This is the stem and leaf given to us. Okay. So let's consider the question number 5. It says Nolan counted the number of silver beads on each bracelet. Okay. We must be given a key. The key should be 2/9 is counted as 29. So they are asking in the question, how many bracelets had at least 30? At least 30. That means the minimum number of beads should be 30. Therefore, it means it cannot be 29, but it could be 34, right? Agreed. So what we do is, other than this value, we count everything else. 34 possible. 42, 48, 40, 54. These are all possible. So let's count 1, 2, 3, 4, 5, 6, 7, 8. So we simply say 8 bracelets have at least 30 silver beads on them. Okay. So what we are trying to do is, we are just trying to process information by counting the values. Okay. If they would have said how many bracelets had less than 30, so we would simply say there was one bracelet which had less than 30, there were 29 beads on it. Okay. Stem and leaf is an easier representation of data where we can find a lot more values like mean, median, mode. We can even find what is the what would be the word? Okay, we haven't done skew or symmetry, but it would also inform us what kind of a symmetry it is. Like if it's positive skewed, negative skewed, we'll have a look later on that, okay? So question number 6 states this information. Just a moment, I'll realign this. A machine at the candy factory dispersed different number of lemon flavored candies into various bags. Okay. So this is the stem and leaf provided to us. That is showing how many candies per bag. Okay. And the question is asking us how many bags had at least 10 lemon flavored candies. Okay. But fewer than 80 lemon candies. They could be at least 10, but they cannot exceed 80. Okay. Okay. For this particular question, question number 7, we are looking at different number of flavored candies. The stem and leaf is provided to us. Let's look at the key. The key should be 1/3, is 13. The key could be different from the given values, right? But 1 and 3 would define us that it is 13, right? I could have written 1/7. Okay, 1/7. Bar means straight line. So the question says how many bags had at least 10 lemon flavored candies, but fewer than 80. At least 10 means this is 13, right? That means this is at least 10. But fewer than 80 means there was number that was 82 is greater than 80, 83 is greater, 84 is greater than 80, 86 and 90 is greater. So what we can see over here is that we need to take these values because 24 is greater than 10. Oh, at least 10. That means the first set of values would also be considered. At least 10 means 13 is included, right? 13 is included, 18 is included, 24 is included, and so on till 74. But 82 cannot be included. Why? Why can we not include the 82? Because 82 is greater than 80. And what we need to consider is fewer than 80, right? So how many bags had this? 1, 2, 1 bag, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So we can say there were 20 bags of candies which had at least 10 but less than 80. Okay, but you do not have to circle all these values. I'm circling these values just for the explanation. What you can do is you can simply count them, right? I've done a difference. I would have to do some workings additional just to prove it to you, just to show you the values, right? You don't do the circling. You just do the simple counting, because if we circle the numbers, we're still wasting a lot of time and we might overlap a number. Okay. So let's have a look at another question. Okay. So another question says, Dalton counted the number of, just a minute, pieces of pepperoni on each pizza he made. Moments, please. Okay. For the next question, it says, Dalton is counting the number of pepperoni on each pizza he made, because sometimes we are sprinkling, so we do not have the exact number. Exact number is not there. Okay. So if this was the question given to us, Question number 8. Question number 8 is saying number of pizzas, number of pieces of pepperoni, right? So when we look at the stem, it has the same heading over here. It says pieces of pepperoni per pizza. The stem and leaf is given to us, right? Stem and leaf is usually given us for the values from 0 to 9. We would not need, we can write those 9 values down, right? Because there's no differentiation between the tens. But if the values are in tens, 20s, 30s, 40s, and so on, then we use a stem and leaf, right? So the question says, let's look at the key. The key would be 1 slash d is 13. Even though 3 is not over here, right? We can only see a 0, 0, 1, 1, and 6. But 3 would still explain what is the key, okay? So they're asking us, how many pizzas had exactly 11 pieces? 11 pieces mean that this would be 11 and this would be 11. Okay? Let's copy this question just to tell you a difference, okay? So if this was our question number A, that means 11, exactly 11 pieces of pepperoni were on how many pizzas? They were exactly on 2 pizzas, right? Okay. Now if I change 1 minute. If I say, what fraction of, in part B, if I'm saying what fraction of pizzas had exactly 11 pieces of pepperoni, so the requirement has been changed. The requirement over here is, it says how many pizzas and it says what fraction of pizzas, right? Just a word difference would change the question. We know that exactly 2 pizzas had 11 pieces, right? But when the word fraction is used, we need to have a numerator and we need to have a denominator. So whenever we are saying 2 out of this, if we say there were 2, if we say there are 18 students in the class and we just, let's suppose, select 2 students, right? So we are simply talking about those 2 students, right, who got 11 marks, or the 2 pizzas which had 11 pieces on it. But when we're talking about the fraction, that means we have to consider the total, the sum, not the sum, the total number of pizzas that are present. So how many pizzas were there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That means 2 upon 20. That means 1 upon 10. 1/10 of the pizzas had exactly 11 pieces of pepperoni, right? A small keyword change can change the question. Let's have a look at another example. Okay. Mr. Gomez is a PE teacher. The next question, just give me a minute. I'll just copy paste. Okay. For the question number 9, it says, Mr. Gomez, a PE teacher, wrote down how much was the weight each student can lift. Okay. And it says at least 58 pounds, but less than 78. Okay. So we have a range over here. Let's enlarge. Okay. This was question number 9. So Mr. Gomez, a PE teacher, wrote down how much weight each student could lift. It has to be the same statement on the stem and leaf, right? So some students could lift 42, right? They could lift 42, 49, 51, 54, 55, 56, 60, 61, 63, 66, 71, and 77. This was a division of the weights. So what they're asking us, how many people lifted at least 58? See, what is the minimum number for 50? That is 51. Then we had two more numbers and it was 56. So we do not have 58 over here, right? If we would have had 9 over here, that means 9 would be included. That means we have to go beyond 50s, right? That means at least 58 means the initial number could be 60, right? It could be 61, it could be 63, or it could be 66. But less than 78, it can have 71, it can have 77. We do not have any number that is greater than 78, right? So how many possibilities are there? 1, 2, 3, 4, 5, and 6, which you can count over here. 3, 4, 5, and 6. Okay, we can say there were 6 people or 6 students who lifted at least 58. The minimum amount was 58 pounds, but they lifted less than 78 pounds. Okay, do we agree on this? So depending on the questions, the requirements would change, right? If I would do the same thing with the question over here, let's suppose, let me copy this. I'll just change one statement in the question, okay? Okay, this was 6 people. Let's put it back over here. Like in the previous question, what I did was I changed one word. Let's change, okay, one word in this question also. This was part A. Let's say this is part B. If I say what fraction of, if I change the word from many to fraction, what should happen now? Now what we need to see is there were 6 people who lifted. We agreed on that, right? There were 6 people who lifted more than 58 but less than 80, right? There were 6 people. How many were there as a total number of people? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That means half of the students are lifting at least 58 pounds, but they're lifting less than 78 pounds. Between, okay, 58 and less than 70. So let's move ahead. One word in the question can make a lot of difference to the answer, right? So always read the requirement very carefully. Okay, let's see. Eva is counting the number of ducks in a pond. Okay, let's see. Eva counted the number of ducks at each pond in the city. Okay, she's doing a survey. Okay, let's see. Okay, can we make the key? Key has to be there for our own convenience. Once bar 0 is 10. This was question number 10 as well. So the number of ducks at each pond in the city. There were 10 ducks, there were 13, there were 23, 38. What is the largest number of ducks? The largest cannot be 10, right? It has to be the last value with the 9. We have a 9, 0 and 9, 0, right? So what is the largest number of ducks? It would be 90 ducks. They can also say there how many ponds were there with the largest number of ducks. Okay, if I would say how many ponds were there with the largest number of ducks. Okay, so how many ponds were there? There were 2 ponds, right? Because 90 is written twice. So we can say there are 2 ponds. But if I would say part C, okay, let's move this over here. In part C, they can say, if I say, what fraction of ponds were there with largest number of ducks? So we know that there were 2 ponds. How many are total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 2 out of 14, right? That means 1/7 of the ponds had the maximum number of ducks. Okay, so we are processing the information in different ways. Okay, let's move ahead to the next question. Let's do a question or two more, then let's do the test. Okay, for the next question, Professor Sharma released the results of yesterday's pop quiz. The quiz is there. Students scored exactly these many points. Just a moment, please. Okay. We do not have the key. We can make a key. We can say for the key, it's written as 1 bar 2 is 12. Okay. This is question number 11. It says, Professor Sharma released the results of yesterday's pop quiz. How many students scored exactly 48 points? Do we have a 48? We have a 45 and we have a 47. We do not have a 50, then we have a 66, right? So, did any student score a 48? None. Okay, so we write 0. 0 students scored 48, right? If I would say, if I will add another part to this question, find the range of scores. So we know that the term range refers to maximum score minus the minimum score. What is the minimum score? 1, 2, 12, right? What is the maximum score? That is 9, 0. So can we say the range will come out to be 78? That means the values of score lie within this range. Why lie within 78 points? Okay, that means from the lowest to the highest, the difference is 78. Okay, good enough. Let's do some questions from the test. Let's discuss them together. Just a moment, please. I need to re-log in. That is 23.5, grade 7, chapter number 23, lesson number 5. We need to go to the test. Let's begin. See, we cannot do the test at the same time because the questions might be interchanged. Okay, so sometimes you can have question 1 as a different question. I will have a different question. So let's do the question together on my screen, and you can always redo them once you do the practice. Okay, so the question says this information is being provided to us. Okay, Mr. Gomez, the PE teacher, wrote down how much each student can lift. We did a similar question already, but in this case, the options have been changed. Okay. At least 58 and 78. Let me resize this. Sorry. Okay. So this is our question number 1 from the test. So what should be the answer? Should it be 6 or 11? They're saying Mr. Gomez scored the results of how much weight each student lifted, right? So we have the stems, we have the leaf. The minimum score could be 20, 42, right? The minimum score is 42 because the stem was 4 and the leaf is 2. Highest score is 77, right? They're not asking us for a range. They're not asking for the minimum or maximum. What they're asking us is, how many people lifted at least 58 but less than 78? Can we see a 58? We can see 56. We do not have a 8, right? We do not have the value of 8. So anything greater than 56 would be greater than 58. So can we say yes? Perfect. 6 is the correct answer. Thank you. Because anything greater than 56 was now 58, right? These numbers, right? So these are the possible weights. Thank you. 6 was the correct answer. Okay, thank you. Let's move ahead to the next question. Okay, the next question says, okay, again a range of scores. Mrs. Blackburn, the science teacher, gave the score for the Monday's test. Okay, just a moment, please. How many students scored at least 34 points but less than 43? So the question says this information. This is our question number 2 from the test. And it states that Mrs. Blackburn, the science teacher, informed her students of their scores on Monday's test. The stem and leaf has been provided to us. We do not have the key. We should prefer to write the key. That means 2 bar 0 is 20, is referring to 20. Okay, in the previous question, 4 bar 2 is 42. So it's preferable to write the key. Okay, so let's move. Sorry. Let's see what are the possibilities. How many students scored at least 34 but less than 43? 43 is not included, right? Fewer than 43 means it could be 41, it could be 42, it could be 42. Can it be 43? No, that's not possible. At least 34. 30 is not at 34. 32 is not. But 35 is at least 34, right? Right? So how many students? Yes, agreed. Thank you. There were 6 students, right? 35, 37, 39, 41, 42, and 42. There were 6 students who scored between this range. Okay, let's have a look at another. Okay, the next question says, at a candy factory, the butterscotch cat. Sorry, just a moment. The butterscotch candies are packed. This is our question number 3. I'm so sorry. Let's look at the options.
the options were 3 and 4. And they are talking about how many bags had at least 16 butterscotch candies. This is the stem and leaf that has been provided to us. Okay, and so for question number 3, it says a candy factory, butterscotch candies were packed into bags. How many bags had at least 16? 16 means 1 6. We have 1 6, right? That means it's included. But fewer than 58. Do we have 8 over here? No, we only have a 1. So what should be the answer? Yes, thank you. It should be 4 over here. Why? Because this is included, and this is included, and this. Only 4 possibilities were included, right? The other possibilities would be out of the range because we have to say at least 16 and fewer than 58. 51 is fewer than 58, but 67 is not fewer than 58, right? So there were only 4 possibilities. So we click onto the correct answer, right? Okay, please do complete the remaining questions, okay? And if there is any problem, you can go through the lesson. Okay? Thank you so much.